Hi guys, this is Miss Weimer. Just wanted to do a little video demonstration of graphing and walking through the steps that are listed on the slide. And so I'm going to take the example y equals 3 sine times the quantity x minus pi over 2. I'm going to walk you through graphing that function. And so if we're following the steps, the first thing we want to do is we want to identify our shifts. So we're going to look for an a value, an h value, a k value, and then we're going to recognize that this is a sine equation. So if we look at, for our a value, that's the amplitude, that's the stretch factor. We see that here with the 3. There's no negative, so it's not flipped, so it's just going to be stretched by 3. When we look at the h value, that's the horizontal shift, and it's in the parentheses. Remember that when it's in parentheses, it's always the opposite direction. So if it's negative, we're actually going to shift the graph to the right pi over 2 radians. And then the last thing that we're going to look for is the k value. That would usually be at the end of the equation or standing alone as a plus something or minus something. And since there's nothing being added to this, there is no k shift or no vertical shift. So those are the 3 parameters that we'd need to identify first to do this. So the next thing that we're going to do is follow the steps to graph it. So step 2 says, using the k value, determine the midline of the function. So a normal sine or cosine graph has a midline at 0. Since our k value here is also 0, there is no shift to this graph, so the midline doesn't change. So the midline of our graph is still right here at the x-axis. Step 3, using the amplitude, determine how far above and below the midline our maximum and minimum values will be. So since our amplitude is 3, normally our sine or cosine graph stretches 1 above and 1 unit below the axis. Since we're stretched by 3, we're now going to stretch 3 units above, make sure you label, and 3 units below the x-axis. And so one thing I like to do is just kind of sketch in my parameters so that I know now that my graph has to be between these lines. The top line is the maximum height, the bottom line is the minimum height, the middle line is our midline of our graph. Let's see, step 4, using the h value, determine the x values of the important points and be mindful of the x-axis scale. So our h shift is going right pi over 2. And normally our sine and cosine graphs are marked by pi over 2 units when we're using radians. It'd be pi over 2, pi, 3 pi over 2, and 2 pi. Since we're shifting to the right pi over 2 units, we can still use pi over 2 as our marker. But since everything is going to be shifted to the right, we're going to need to go a little further than 2 pi. So the next step after 2 pi, if we're counting, the first one would be 1 pi, 2 pi over 2, 3 pi over 2, 4 pi over 2. This would be 5 pi over 2. Okay, use your knowledge of the parent function, sine or cosine, to determine the y values of the important points. We said that this is sine. And we know that the sine graph typically starts at the midline. And those are our y-intercepts. And that's going to be the case, those are our x-intercepts, and that's going to be the case for this graph as well, since there's no h or k shift, there's no vertical shift. So our intercepts are normally at 0, pi, and 2 pi, right? Those would be the normal sine graph. But in this graph that I'm going to graph in, I think I'll graph this new graph in green. Actually, let me pick a whole new color here. I'm going to graph the new graph in purple. We're going to shift each of those points pi over 2 to the right. So this original red dot, that would be our normal sine graph, is going to be shifted to be here, pi over 2. The original middle of our graph, which was pi, is going to be shifted pi over 2 to the right, so it's going to be 3 pi over 2, and the end of the graph, or the end of one cycle of the graph, would normally be 2 pi. It's now going to be shifted here. And then we know that the sine graph goes up first. Step 6 and 7 is just filling in the rest of the points. So sine, as long as it's positive up here, +3, it goes up first. So it's going to hit a high point between our first 2 points. So that's going to be up here at pi, and it's hitting the top of our sketch. And then it hits the middle, and then it hits a low point down here at -3, and back to the end. So our new sine graph with all the shifts is going to look like this. Remember that trig functions are cyclic, so they repeat. So you have an arrow here that's going to continue the graph going this way. You have another arrow that's going to continue the graph going this way. And that's one complete cycle of y equals 3 times the sine of x minus pi over 2. Hope that helps.